In this video, we will describe the adjustment procedure for the front recognition camera and explain why it is very important to follow the repair manual procedures when performing any ADAS calibrations. We'll also highlight information, resources, hints, tips, and methods for performing this front recognition system camera calibration. The front recognition camera, or FRC, is mounted at the top center of the windshield, and it's an important input sensor for several different ADAS systems. ADAS is an auto industry generic acronym that stands for Advanced Driver Assistance Systems. Some of the ADAS functions that depend on the FRC as an important input sensor are Pre-Collision System, or PCS, Dynamic Radar Cruise Control, or DRCC, Lane Departure Alert System, LDA, and Automatic High Beam System, AHB. The pre-collision system uses the front recognition camera for object classification information together with distance information from the millimeter wave radar sensor to determine that the possibility of a collision is high. PCS also provides audible and visual warnings to the driver of an imminent collision. When the PCS on this 2019 Camry determines that the possibility of a collision is high, pre-collision brake assist control is performed. If the driver applies the brakes, the brake control system is primed for maximum deceleration and controlled braking. When the PCS determines that a collision is imminent, pre-collision braking control can be performed to help avoid and reduce the impact of the collision. The front recognition camera is also an important input sensor for the Dynamic Radar Cruise Control (DRCC) system, the Lane Departure Alert System (LDA), and the Automatic High Beam System (AHB). The front recognition camera system also self-monitors for system performance. A misaligned FRC can result in diagnostic trouble codes. Examples of these codes include C1AA9, front camera module beam axis not adjusted; C1AA8, front camera module incorrect axial gap. The result of not performing a calibration when required by the repair manual or not performing the calibration accurately will be the DTC shown. Whenever replacing, removing, or installing the windshield, always use a genuine Toyota part. The position of the camera mounting bracket, the black ceramic border, and the transmissivity of the glass are critical for proper FRC performance. We very strongly recommend that before beginning your first front recognition camera adjustment procedure that you read the document shown on the screen. This document is named Cruise Control Front Camera Before Starting Adjustment. For a 2018 Camry, this document is located in TIS under Repair Manual, Engine Hybrid System, Cruise Control Front Camera. Before starting adjustment, the document covers the environmental conditions that can cause problems with the FRC adjustment, important criteria for target shape and contrast, the importance of ambient lighting on target recognition. Another good source of information is Toyota Service Bulletin TSB 018417. An overview of the FRC adjustment procedure includes: secure an appropriate area for performing the adjustment. Make a high contrast target of the correct size and shape. Create a vehicle center line projected in the front of the car. Make a line at 90 degrees perpendicular to the center line at a specific distance in front of the car. Mark 3 target positions on the center line and the perpendicular 90-degree line. Place the target at the specified positions and use the text stream to perform the adjustment procedure. By following the procedure in the repair manual, we will use tape and string to create a vehicle center line that extends about 3,000 millimeters in front of the front recognition camera on the center line. Mark 2 points on a perpendicular or 90-degree line drawn at the 3,000 millimeter mark. These 2 points will be 550 millimeters on either side of the center line. Please keep in mind that throughout this video the measurements are specific to the year and model of car shown. Refer to the repair manual for the specific measurements for the vehicle you are calibrating. The basic equipment required for front recognition camera adjustment is simple: a plumb bob, string, tape, a marker, a tape measure, and a tech stream. Later in this video, we will talk about some of the optional equipment that may make laying out the lines and making the measurements easier or more accurate. The demonstration in this video will make all of the measurements in millimeters. Using millimeters eliminates conversions, both millimeters to inches and converting decimal inches to fractions. A tape measure calibrated in metric units helps ensure accuracy in laying out the measurements. It is critical to accurately determine the vehicle's center line, and because this ADAS calibration is based on the vehicle's center line, there is a very important factor to consider. The center line of the body must match the thrust line of the vehicle's alignment. If the thrust line is not correct, the vehicle will dog track as it travels down the road. When a vehicle dog tracks, the center line of the body is not pointed in the true direction of travel. The repair procedures for many of the front recognition camera diagnostic trouble codes start with making sure that both ride height and alignment are correct. To begin the procedure, position the car in the shop with an area at least 3 meters by 3 meters in front of the car. Ensure that the area is clear of any objects or obstructions. Make sure that the area where the car is parked is flat and level. Adjust the tire inflation pressure to the specified pressure. Make sure to clean the windshield, as any dirt or grime can cause difficulties with the calibration. Print the target and inspect it. Make sure that the target matches the size specification, in this case 180 by 180 millimeters. Check that the target is non-reflective, square, and borders are clear and sharp. To set up the target, cut a piece of cardboard to 190 by 190 millimeters. Mark vertical and horizontal center lines on the back side of the cardboard. Attach the 180 by 180 millimeter target to the 190 by 190 millimeter piece of cardboard with double-sided tape or glue. Remove the reflector from Special Service Tool 09870-60000 and attach the target to the reflector with double-sided tape. Make sure that a black square is on the top right. Align the vertical center of the reflector with the vertical center line on the back of the target. Align the bottom of the cardboard with the mark-off line on the reflector. Cover any remaining reflective surfaces with masking tape. Install the reflector to the stand and use a plumb line to make sure that the center line of the target aligns with the center line on the base of the target. Set the height from the center of the target to the ground at the specified number, in this case 1,350 millimeters. In case there are problems with target recognition, place a large piece of flat cardboard with no markings behind the target. As shown in the repair manual, a wrinkle-free light-colored plain cloth could also be used to block background objects that might cause target recognition issues. The first step is to locate Point A. Point A is located on the vehicle center line at the rear bumper. Hang a plumb bob over the center of the rear emblem. Flick the string to make sure the string is centered on the emblem and hanging straight down from the rear bumper. Mark a small cross on the floor to show both the center line and the position of the rear bumper. This point is designated as point capital letter A in the repair manual. Stretch a line from the rear mark, point A, and tape it down so it covers point A. Toss the string toward the front of the vehicle. You'll pick it up later. Repeat the previous process to locate the center line at the front of the vehicle. Mark this point with capital letter B. Point B on the vehicle center line is at the front bumper. Stretch the string you tossed earlier to about 3,000 millimeters out in front of the car, making sure that the string crosses the front center line mark, point B, and tape the string down. Double check to make sure that the string is directly over both point A and point B marks. An assistant helps make establishing the center line easier and more accurate. Measure and mark point capital letter C on the center line, 267 millimeters, in front of the front bumper. Measure and mark point capital D on the center line, 1,937 millimeters, in front of the front bumper. These measurements are specific to this year and model car. The next step is to create a line that crosses the center line halfway between points C and D. Use a 1,000 millimeter long string attached to a marker. Start at point C and draw an arc to make line E. Then repeat this process to draw an arc on the opposite side of the center line to make line H. Now, move to point D with your 1,000 millimeter line and marker and draw an arc creating line F. Again, repeat this process on the opposite side of the center line, drawing an arc to make line I. Point G is where lines E and F cross, and is one end of the line you will use to mark the target positions. And the point where lines H and I cross is the other end of the perpendicular line you will use to mark point J. Stretch and tape down a string line to connect the points you found to define the perpendicular target line. You have just drawn a perpendicular line that bisects line segment CD. The point where the perpendicular string crosses the center line string is point K, the center target position. With your tape measure, confirm that points G and J are 550 millimeters out along the perpendicular line from point K. Now you need to double-check the target positions. By measuring between points G and B and points J and B and doing some math, you can verify that the perpendicular string is a true 90 degrees to the center line. The measurements and math also confirm that points J, K, and G are positioned correctly. Now we need to verify that point K is correct, so we need to do some math. The line from point B at the front bumper to point D is 1,937 millimeters long. The line from point B to point C is 267 millimeters long. By subtracting, we can determine that line CD is 1,670 millimeters long. Line CD is the line segment that we bisected by drawing the arcs and laying out the perpendicular string. Since bisect means to divide in half, 1,670 divided by 2 equals 835. Line CK is 835 millimeters long. Line CK, 835 millimeters, added to line BC at 267 millimeters equals 1,102 millimeters. That means that point K, the center target location, is 1,102 millimeters down the center line from point B at the front bumper. Now we can use that old nugget from geometry class, the Pythagorean theorem. A squared plus b squared equals c squared. In this case, line bk squared plus jk squared equals bj squared. 1,102 squared plus 550 squared equals 1,516,904. The square root of 1,516,904 is 1,232. If line BJ is 1,232 millimeters long, then the perpendicular line is truly 90 degrees to the center line, and points J and K are in correct position. There are many online Pythagorean calculators available to simplify the math. Toyota Tech Tip T-TT-0515-18 and Lexus Tech Tip L-TT-0252-18 make it easier to print the full range of correctly sized targets. Toyota Tech Tip T-TT-0503-18, and Lexus Tech Tip L-TT-0245-18 provide hints and tips about using alternate equipment to lay out the various lines needed for multiple calibrations. Tech Tips 0503-18 and 0245-18 also include a forward recognition calculator to automate the calculations we just covered. Remember that Tech Tips expire 1 year after the date of publication, which is shown in the upper right corner. Now that target positions G, J, and K are correctly marked, it is time to connect the tech stream to perform recognition camera target position memory. Connect the tech stream to DLC3. Turn the ignition on, engine off. Turn the tech stream on and launch the tech stream program. Select Chassis, Front Recognition Camera, Utility, Front Recognition Camera / Target Position Memory. Confirm the conditions and select Next. Click Next and enter the values from the repair manual. Select Input. Use the mouse to enter the numbers. Don't forget to click OK. When all the numbers have been entered, select Exit to return to the Utility menu. Now select Recognition Camera Axis Adjust. Select Next. Check the numbers that you just entered to make sure they are correct. Then select Next. Confirm the conditions and select Next. Select Sequential Recognition and then select Next. Set the target at position 1, center, and select Next. You'll see a progress bar advance during the target position 1 calibration process. Now set the target at position 2, left of center, and select Next. You'll now see a progress bar advance during the target position 2 calibration process. If the calibration has failed and you have followed the procedure closely, it is usually due to the front recognition camera not being able to differentiate the target from the background. Ensure that the background behind the target is not backlit, reflective, or does not have reflective objects in view. To resolve this, have an assistant hold a large flat sheet of cardboard at least 840 mm by 840 mm with no markings or creases closely behind the target. Or, as shown in the repair manual, a wrinkle-free, light-colored plain cloth could also be used to block background objects that might cause target recognition issues. Then select Yes on the tech stream screen. Follow the on-screen prompts just as you did before. Have an assistant hold the cardboard behind the target at all 3 positions. When the issue has been resolved, you will receive confirmation that the recognition camera axis adjustment is complete. Select Exit to exit the calibration program. Thank you for taking the time to watch this important procedure. The front recognition camera, like other ADAS systems, requires calibration procedures to perform their functions. Remember, the repair manual is the best source for calibration procedure information, and the New Car Features is an excellent resource for operational details on this and all other ADAS systems.